If this is clear, let's move on to a few questions. So the first question, we'll solve it together. So in gradient intercept form, find the equation of the line passing through this point with gradient 5. So now let's work on this. So we know the formula of y minus y1 equals to m into x minus x1. Now let's plug in the values. So this will be y minus of minus 3, and then m would be negative 5, and x would be 7. So now let's simplify it. So this is our answer. Let's verify if that's actually the answer. Yes, that's what we also got. So now let's solve the next one. So same formula. So y minus of minus 2 will be plus 2. Negative 3 into negative of negative would be plus. So now let's simplify this. So this is our answer. Let's see if, yeah, so it's negative 3x, negative 5. Let's solve the last one. So this is our answer. Let's solve the next few questions. So in general form, find the equation of the line passing through this one. So we have to find in general form, which is ax plus by equals to c. So now let's use the same formula in the start. So that will be y minus 0. So let's just leave that. And then negative 1 by 3 into x minus 5. Let's cross multiply. So that will be 3y equals to negative x plus 5. So x plus 3y equals to 5. That's the answer to the first one. Yeah. Let's solve the next one. Same formula. Plus 3 because negative equals to negative 2 into x minus 5. Let's expand this. And then let's bring the x term to this side. So 2x plus y. And then this to this side. Equals to 7. So that's our answer. Yes. And now let's solve the final question. So y plus 2 equals to 6 into x plus 7. And now let's simplify this. Let's solve the last set of questions. So we have to find the equation of the line passing through the following points. So yeah, let's do that. All right. So we have to find the equation of the line passing through this. So yeah. Okay, so we have the coordinate of the point A and B. So first let's find the gradient. So the gradient is the change in y by change in x. So negative 2, negative of negative 2, divided by 4 minus of minus 1. That is 0. So let's use one of these points to find the equation. So y plus 2 equals to 0 times x plus 1. This will be 0, so y equals to negative 2. That's our equation. Yeah. So now let's solve this one. Let's find the gradient first. So 1 minus 0 divided by negative 3, negative 2. That's 1 divided by negative 5. So y minus 0, we'll just leave that. So that's negative 1 by 5 into x minus 2. Let's simplify this. Let's cross multiply to actually simplify it. And that's our answer. Yeah, so they added a gradient intercept form, which is this, or you can write it in this form also, general form. So now let's solve the final question. The gradient will be 2 divided by 4, because 2 minus 0, 3 minus 1. That's 1 by 2. Let's use this coordinate. So there is no y coordinate, so that will be y equals to 1 divided by 2 into x plus 1. That will be y equals to 1 by 2x plus 1 by 2. This is in gradient intercept form, and let's write in the general form. So x minus 2y equals to 1, negative 1. That's general form. Yeah, we got our answer. Moving on to the harder questions. So yeah, let's work on this. So we have to consider the following points, which is P with coordinates -2, -3, -2, and Q 1 by 6. So a line perpendicular to this line passes through Q. Okay, so now we have to find the equation of the line. Okay, now you can see that we haven't really been given any information in terms of this slide, right? So you have to think about it intuitively. We don't know the gradient, we just know a few things, which is not really, in this slide. So now let's just think about what we can do. Okay, let's see what we've been given. So we know that a line is perpendicular to PQ. So this implies that whatever we find, the gradient that we find here is going to be the negative reciprocal of the gradient of the perpendicular line. So now let's find that. Okay, so now let's find the gradient. So the gradient would be 6 negative -2 divided by 1 negative of -3. So that's 8 by 4, which is 2. So now that we have 2, we have to find the negative reciprocal in order to find the gradient of the line we're trying to find. So the negative reciprocal would be 1 by 2. So this is the thing. And then it also says that it passes through Q. So now we have the following details: the gradient and a line and a point. So now let's just use the regular formula that we always use. Okay, now let's work on the next question. So we have to find the coordinates of the point where the line cuts the x-axis. So when it cuts the x-axis, the value of y will be 0. So when we plug y equals to 0, we know this states that x will be plus 13. So the coordinate would be 13, 0. So now let's check if that's the answer. Yeah, this is question number 1, question number 2. So yeah. The next question states the following. Suppose A has the coordinates of negative 7 comma 4 and B has coordinates of 3 comma negative 2. A line parallel to AB passes through C, which is 5 comma negative 1. We have to find the equation of the line. Okay, so we know that if a line is parallel to another line, the gradient will be the same. So now let's find the gradient. 4 minus of minus 2 divided by minus 7 minus 3. So that's 6 divided by negative 10, which is 3 by negative 5. So the gradient of the parallel line will also be the same. And we've been given that it passes through C, which has coordinates of 5 comma negative 1. So y plus 1 equals to 3 divided by negative 5 into x minus 5. So let's cross multiply. So 5y plus 5 equals negative 3x plus 15. So let's do this. Let's simplify. So this is, yeah, so this is, okay. Okay, so this is our equation. Okay, now we have to find where it cuts the x-axis. So when x equals to 0, then we find the point where it cuts the x-axis. So let x equals to 0. So 5y equals to 10. Okay, so 5 will be 2. Therefore, the coordinate would be 0 comma 2. Okay, let's check our answer. Yes, this is also what we got.